Hello everybody, welcome and thank you for coming out to the 9th live stream here. I just can't believe you guys are still watching this after all this time. Um, at any rate, tons of stuff has been done by a wide variety of people. People like Geekmaster over in Discord have been trying out the Vive with different pieces of hardware such as the Raspberry Pi, the Odroid, various Intel cards, NVIDIA cards. One of the things that, even though we don't have anything right now to plug it into code-wise, we want to make sure that we're going to get as much hardware as possible that can output to the HTC Vive. Now you might say, oh, but why not? Don't you need like a really powerful video card? And the answer is flat out no. I can run GLX gears, which isn't very much, on my Intel card, and so that's one thing I know can work. But we're right now trying to figure out, is there any way to get the Vive to work on a Raspberry Pi? Is there any way to get the Vive to work on all of this other stuff? And so he's been doing a lot of work figuring that one out. Additionally, MW Turvey, I don't actually know what handle he goes by, but he's been doing an enormous amount of work with having the Steam tracker and being able to get that all integrated to the rest of the system. So right now I believe he has that done in wired mode, but not done in wireless mode. Additionally, LibSurvive now has support for Windows and OS X, and in Windows it supports both TCC if you don't want to install Visual Studio, and it supports Visual Studio, both of which now support the full driver registration models, so different drivers for the Vive can be written and just used without having to change any other code. So you can just go link in a new driver and it just works. And yes, no, not 1080p. Definitely not 1080p today, since I'm actually streaming from my laptop right here. Right there. And I'll be working on my computer. But that is because hopefully we'll get to at least trying to print a circuit board and maybe seeing what the analog value looks like. I only have about 3.5 hours, so it's going to be a bit of a stretch, but I still want to try it. So MW Turvey with the Steam tracker. David Chapman has been working tirelessly to figure out a better way to do, hold on here. LibSurvive, git pull. David Chapman has been working on a poser. So the LibSurvive is now split into separate systems. The first part of the system is where you take on data comes from devices, and these devices are called things like survive_vive is right now I think the only poser or only data source that we actually have. And what it does is it collects data, light pulses and IMU information, and it directs that into survive data. And survive data gets these codes in handle light cap. And, that's another thing. People have been working on newer disambiguators. So, going back to that, at any rate, so data comes from devices. It then goes into something called a disambiguator, which figures out, based on, I saw this pulse here, I saw this pulse here, I saw this pulse here, what the angle of view is from the lighthouse. Then, from there, it can go into either the calibrator or the rest of the system. So under survive process.c, the data comes in from the light caps, and then we haven't actually coded it yet, but theoretically we're going to be able to use the base station OOTX data, which Neral I think has a pretty good idea what does. We're just going to have to trial and error once we get a little bit further and once we can actually validate our results. So what this means is we'll take the data that's coming in from the lighthouses and then we'll see, hey, does that produce a good solution or does it produce a bad solution? And if it's a good solution, well, then we have a pretty good idea that our data and what we're doing to it to handle the cal information from the lighthouses is correct. Otherwise, well, we're gonna just have to keep troubleshooting that. So that's there. And then the data is passed off to right now it's passed off to posers and the calibrator. And we have posers such as poser Dave Ortho or poser Charles Slow, which handle angle information, and then computes the orientation and all of that of an object based on it. So one thing I can do right now is make -c Dave /data recorder pipe Dave ortho plot. This is just Dave's mechanism for visualization here. Let's see if I can get that to... Oh, come on. Why are you not going? No, it's not plugged in. Let's try that again. Okay. And so here is Dave's ortho plot, where he's trying to use affine transformations to figure out the pose of the Vive headset. And so the red points are the points that we're seeing from the lighthouse's point of view, and the blue points are where we would think we should see those points if we were to run his code against it, and it tells us, hey, by the way, the headset is right here, and it has this orientation and rotation and all of that. So you'll see that there's still some bugs, so it still doesn't line up perfectly, especially at glancing angles, and when you get pretty close. But in general, it's operating pretty good. So I think as far as we'll really need, Dave's solution is almost there. So that's going to be really cool once that gets integrated. Whole thing is, I'm not a math guy. I am a hardware guy and a microcontroller guy. I'm barely even a software guy. So I'm going to finally, this is the first live stream, I'm going to get a chance to do what I want to do. What I want to do is build some hardware. So, you guys have questions, so just be clear, the disambiguator doesn't require calibration data to work. No, the disambiguator does not require calibration data. The disambiguator simply gives you raw angles. After that, you have to use the OOTX data, which we are collecting from the lighthouses and we're storing, though we just don't necessarily know exactly what to do with it yet. As you can see, it actually stores like the fcal phase, fcal tilt, fcal curve, fcal whatever that is. All of these aspects from the lighthouse we're storing. We also don't have the pose information coming, being built from the pose information that Dave has provided, but that's just a matter of, you know, some of the other people on the project getting together and figuring out, okay, we got these three objects here, and this is how this works, this angle, and putting it in there. So things are really, really starting to look up. Using ESP and run Crisis on that Vive. That is the goal. Probably not Crisis, though. Although I guess it is possible. What was it? Didn't he? No, it was Witcher. They ran Witcher on an ESP32. Sprite TM is just insane. At any rate, so all the stuff is great. Everything's great. I think it's neat. And you can totally just buy this chip from wherever it is, something semi, which will take in light data and basically give you a, how do you describe it? It's basically, here, let's see if I can pull it up. Steam chip, Vive chip. VR amplifier. Nope, 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 nope. Does anybody have what the chip is? Because I, for the life of me, cannot remember what the chip is that you can currently buy. But so the problem is, oh, I got to install Paint. Ah, TS3633. That sounds familiar. Digital converter for Steam VR tracking. So this chip right here, I don't know if they have a, here. So what it does is it takes in the infrared light with the bias, and it produces an enveloped output. And it's going to take a little bit to install. Oh, actually, you know what? I forgot how fast my internet here was. Hi, Reed. Yeah, no, I'm not going to go by your part right now. At least not until I give up trying to do what I want to do. So what you actually get coming from the lighthouses is something that looks that it's a modulated signal. So you basically get this infrared coming from the lighthouse, and whether it be sweeps or it be flash, it's going to just have this modulated signal, and it's going to kind of look something like, it's not quite like that. I guess it's a little more like, and the reason behind that is because when you have a modulated signal, you can use a high-pass filter, and you can then only look for light that's being transmitted at about 1.8 megahertz, and that's cool, but what they're really doing here is some fancy electronics in order to take this signal right here and then boost it up. And then what they'll do is they'll take this boosted signal and then they'll pipe it through a diode. Now it's a little bit fancier than that in reality, but what that does is it means that you'll have this signal right here and it will output kind of like this enveloped thing. And that envelope shape depends on the where these things start, where they stop, and you can pull a lot of information out of this, and you can actually really get like the pulse length and a lot of other information, and that's all passed off. And all of this is actually done in an FPGA inside of the various Vive controllers, whether it be a controller or the headset or whatever. And that's fine and dandy, but I think I can do better. I say that arrogantly, like I don't actually know if I can do better, but it's one of those things. Like my mentality is like, I'll just always assume that I come to the table with different knowledge than anybody else, the same as any of you guys watching would. So I would always urge you, never assume that, oh no, somebody smarter than me came up with this, I can't possibly contribute anything. Most of the time you'll find out that's true, but let's just go for this. Let's just check this. So instead of doing this, I want to scrap this chip altogether, and what I want to try to do, and I understand it's probably going to cost more in the end, but considering ESP8285s, which are like an ESP8266, just with built-in flash, they are, I'm not even allowed to say how cheap they are, but they are less than $2.10 by a lot. That's the lowest I can tell you the number for. And by the way, if you want, you can buy some ESP8285s. They're a single chip, like Wi-Fi solution. We're not going to use them for Wi-Fi, but they're really cheap. So what I intend to do is I want to have this signal right here. I want to pipe it into a high-speed op-amp. Of course, I'm going to have a little bit of filtering and stuff like that. Actually, that's probably going to look more like this, and maybe that. But what's going to happen is I want to be able to get this signal out, and what I want to have is something that's got a fairly big signal here, and I'm going to use the Schmidt trigger on the input of the ESP8285. The I2S I pin, and I think it's GPIO 12. And what I'm going to do is I'm going to take in this wacky signal, and it's going to digitize it into a square wave for me. And the cool thing about the ESP8285 is it's got an 80 megahertz shift register on that sucker. So I'm going to be able to sample this incoming signal at 80 megahertz. Now, chances are I'm not going to be able to keep up in processing, so I'm probably going to have to drop it back to 40. But I want to see what happens if I look at this input signal and I try to figure out more information about what's going on. maybe I'll be able to figure out orientation. Maybe I'll be able to figure out much more accurately where in the sweep it was. Because right now, when the thing is sweeping, it might be sweeping from here to here, and the light might be visible from there to there. But maybe the wave started right there, or maybe the wave started right there. And you'd have a jitter of about 1.1 over 1.8 megahertz. Yeah, and no FPGAs. ESP8285 is better FPGA for what I'm trying to do. And no way am I going to use an STM32. I use those commercially because they're expensive. Ooh. Also, the ESP8285 can totally go faster, so I have absolutely no interest. Basically, when the ESPs came on the scene, my interest in anything STM basically went down the tubes. Because, especially with the ESP32, it kicks the snot out of every single thing ST has to offer. Anyway, back to work. So what I want to try to do is that. I want to try to get this thing working. And I did go, when I went to DigiKey, I did find an interesting part. And actually, I found it. I bought a whole bunch of different op amps, so I'm going to try them out. But what I did find and what I did buy is this guy. It's really cheap. It's 27 cents a quantity, and it's got pretty good gain at a fairly high frequency, which is really useful to me. And so what I intend to do is to try to use this guy and have it all set up. There's only one problem with this. This part really requires a plus minus 5 volt swing. And I want to be able to operate this on 3.7 volt batteries. So one of the other technical hurdles we'll have is I'm going to have some sort of charge pump or something set up in order to take the voltage, the 3.7 volts or 3.3 volts, I guess, which is coming into the ESP, and kick it up to something that I can actually use. And so, let me see if I can log into Sim. Is that it? No, that's not it. Part Sim, that's what it is. Let me move it over here so I can get logged in. That was fast. Open charge pump. So what I intend to do is have a circuit that's a little bit like this. And I'm going to use two of the GPIOs on the ESP8285, or for this prototype, an ESP8266. And I'm going to go try to drive this charge pump. So even though these only go up to, let's see, what did I set them to? Oh boy. Ugh, it's actually impossible. People who develop web pages like this, man, they really gotta fix that. Maybe if there we go. I can just scroll and zoom out. Pulse value 2.9. So that means that the voltage on here is 2.9 volts, 2.9 volts. But if I set up a probe, I think it's right here. Add probe 6. So what I can do is by pulsing these, I'll graph those two things too. I can actually get a little bit, what do you call that? Let's see, how do I run the report? Run, there it is. Transient response, sure, let's go for it. That's probably right, because I think it saves your last settings. Oh, this is a negative synthesized drill, which is fine, just so you guys can see it. Even though all I have is a 0 volt or a 2.9 volt output, this circuit can synthesize, oops, How do I zoom out? Reset zoom. This circuit can synthesize a negative 6 volt voltage. So that's going to be really useful in order to be able to use other types of op amps that don't do rail to rail. Don't know if it's going to work out. And neat thing is, if this does work out, I'm going to be able to actually use this in other designs where I need to have negative and positive voltages. For instance, that meter that I want to make, I can actually, if this works, I could theoretically dump the 9-volt battery and make the ESP synthesize the negative voltage required by the voltmeter. So this is one of the two designs. Let's go. The other design, I'm going to have to flip some things around, which I should probably prototype first before I go too buck wild. Resistor DAC? I don't know what you're talking about. ID something something. Anyway. So this is one part of the charge pump. I'm going to have to create another part of the charge pump. But we'll have to try that. So let's save as charge pump 1 plus. So the plus side of the charge pump, what that uses is something that looks a little bit like this. So instead of hooking it up to the ground rail to the basis, what we can then do is we can hook up the positive rail to the basis. And the way part sim works, a little bit weird, but you do that by hooking up that. So I'm going to just do, it's going to be none DC 3.3. And, ooh, that's weird. Let's just delete these connections since part sim does not seem to do well with that. I think all I have to do is flip these around and it should produce a circuit that would do what I want. Don't know. I usually don't actually do charge pumps. Normally what I do in more commercial things is I'll use an inductor and actually make like a switch mode power supply. But, you know, whatever. I don't think I can get this to work really cheap with an inductor, so I'm probably not going to try. Yes. Thank you, Mark. I did not realize you were watching, Mark. Mark, we're going to have a heart-to-heart about LibSurvive because I really think it's getting close to the point where you could have a lot to offer. Anyway, going to give this a shot now. Let's run it. I have no idea if this works. Oops, I forgot to probe the output. Probes. Boop. Okay, run. Run. Sweet, look at that thing. It's producing positive 9 volts. Okay. So this looks like it's probably about what I'd want to actually use. I'm just roughing it here, just guessing. Oh, hi Super Soaker. Oh my gosh, everybody I know. So what I'm going to do is I'm going to take these two circuits and I'm going to draw them up in KiCad here. And what I'm going to use is I'm going to use GPIO, let's say 13 and 14 for that. Do I really want to do it that way? How am I going to do this? Maybe. Actually, I don't know. 9 volts, that's probably enough to just operate the sucker. Wouldn't be able to go all the way low, but that's okay. You know what, let's just... Why bother doing something right when you can do something that might work? Even if it's really bad. Let's do that. So instead of having the negative side, I'm only going to have a positive side for my charge pump here. Unless somebody sees something that's really wrong. I don't think this is bad, so let's just give it a shot. So GPIO 12, that is actually the I2SI. And that is specifically the pin that you can sample at 80 megahertz on the ESP8266/ESP8285. And GPIO 13 and 14 are going to be the ones that I'm going to go noodle around in order to make the charge pump work. A little bit of added reading if you guys are curious. Charge pump. If you just look up the Wikipedia page on it, they'll actually just give you an example circuit. Looks really similar to mine. And what you actually do to make it go. My gosh, it really does look similar to mine. I think it's, oh, I got one less diode stage. Whatever. It just means the voltage will be a little bit lower. At any rate, so what I'll have to do is turn off and on 13 and 14. Timing doesn't really matter. I can just do it on an interrupt or something like that. I don't know. Figure out something eventually. So for right now, let's go figure out how this is actually going to go be all wired up. It's going to be there. So what I also have is, let's see, I bought some diodes too, so I can just use those. I think it's in this order. Ooh, this looks convenient. I think for this first one, I'm going to go use this one. This looks spectacular. Let's see if KiCad has some diode arrays. They probably don't. Preferences, libraries, add. Oh, this is a new KiCad installation. And I don't remember how to import libraries, so I'm just going to go make my own. Let's say new part. Diode array, SOT23. Actually, is it SOT23 or is it a? Yeah, it's SOT23-3. And we're going to go throw some things in here, such as pin 1. Or pin 1 is +1. Pin, I think it's 2 is minus. -2. And 3 is common. Yes, the circuitry will only be able to sample data from one photodiode, but it's so absurdly cheap. Why not? There's another big benefit of this. By having it only one per processor, it means that that processor can then be used to process the data from the photodiode. So if I find there's some sort of heuristics I can use or magic in code that would ordinarily be prohibitively difficult, like I would have to spend time to go do it, if I go code an object with 32 sensors, that has 32 ESP8285s. 32 ESP8285s is actually 3260 megahertz processors, or for an effective 5 giga, whatever it is, giga drystone MIPS, 5 giga GIPS, whatever. Tons of processing power right there on the things that are able to pull the light data off. And as long as I can do it pretty quick, then it's going to be great. So this buys me a lot of extra computational power in addition to all that. So maybe I could send higher level things, such as running the disambiguator inside the sensors themselves, and then only passing the angle data out. So let's check this data here. DMA, yes. ESP 8285s have DMA that sample the 80 megahertz, put it into a buffer for you, and then call it sweet and done. This one. 1, 2, 3. Okay. So I'm going to go place this guy right here. Okay, maybe I have to go import it. Add electrical KiCad. Actually, let's go up a folder and add that to my favorites bar. Modified. Diode array. Right there. Oh, wait a minute. You're correct, I definitely mapped that wrong. 32 times 160 is... Oh, that's right. So I could run the... So there's really two solutions I could use for this. One, I could use the ESP8285s at some stupid high speed, like 300 something megahertz, and then use the I2S out pin, and then use something like a code division multiple access output stream, which I will define in software. And then you could just use a little software-defined radio to receive all of the signals from all of the tags. That's one option, but it does probably violate a lot of FCC rules, so I don't really want to do it. What I do intend to use is the ESP8285 clocked at normal clocking, not connected to a Wi-Fi network, but using raw 802.11 frames to send. And then I can have multiple receivers. So I intend to use diversity with this. So I'll have 3 or 4 receivers. So no matter what, that signal's going to get through. And I'm going to be able to send them at some stupid high rate, like 72 megabits per second. So it's going to use virtually no airtime. So I should be able to slap in like hundreds of these things in a small area, and it shouldn't be any real issue. And no, I don't think the ESP8285s are going to be able to do pose solutions. But what I could do is say I could make them output on their serial pins, and then the serial pins could all go to one ESP32 for a specific device. That ESP32, with the help of all of those ESP8285s, is probably almost certainly enough to do pose solving. And so much so, what I'd love to do is to take that ESP32 and then have 2 more that drive high-speed OLED displays. I want to make my own headset. I think it'd be just so much fun. It's just so cool. Whether or not I can do it, don't know. I'll have to solve this thing one step at a time. Okay. Uh-oh. 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 Oh no. Uh-oh. It's not good. What did I do wrong? Okay, let's try that again. Add KiCad bottom diode array. Oh, it's already in use. Huh. Whatever. Let's go slap that in there. Actually, you know what? Let me do. I should add KiCad everything in here. Okay, so here what I can do is I can use this little 3.3 volt thing there. And I can use, let's use a capacitor array. Network 1206. Actually, I should probably move this out over here. And theta 1 and theta 0. And I'm going to go, so if this right here hooks up like that, I would have one more of these over here. I'm going to hook these two guys together. I'm going to tap down there. And so that looks an awful lot, conveniently, like this right here. So 3.3 volts in, yada yada yada. Boop boop doop. 1, 2, 3, 4. So that would be theta 1, theta 1, theta 0. This would have to be ground. Ooh, this is not going to be good. It's going to have a ground there. This is going to be a pain. Okay, well, whatever. Plus... Uh-oh. Whatever, let's call it 12. I'm going to have to figure out how to get those libraries installed on KiCad. I just don't know how to do it off the top of my head, and so that will have to wait. Let's see, other people asking in chat. KiCad, yep. It's definitely KiCad. Don't worry, this is KiCad. KiCad all the way. I love KiCad. KiCad. It's probably not called KiCad. I think somebody, like the official developers, do call it KeyCad or something weird like that. Not me though. Let's also try to protect this. So I want to have that there. Let's see here. Let's go drop in that op amp that I want to try. So that's this one right here. Let's close some of these tabs. The ESP8285 does not have an FPU. The ESP32 does have an FPU. Now, much to my frustration, Tenselica, the people who make, or it's actually Cadence now, who make the core for the ESP32, the instruction set itself is proprietary, which I think is insane. I emailed them, they haven't responded. If anybody else has any contacts at Tenselica or anywhere like that where they might be able to get the instruction set, that would be awesome. But they don't. However, the ESP32, through other means we now know, has reciprocal floating point, reciprocal square root, and other things like that, where they can do these operations instantaneously. It's like 2 clock cycles or something to do reciprocal square root in floating point. So it's a fast little bugger, but it's stuck behind all this proprietary junk. Like you just can't get an up-to-date instruction set for the ESP32. It's not Espressive's fault, it's specifically Tenselica's fault, and I think if they want to start competing with ARM, which they probably should, they're gonna have to make their instruction set open. Like, why is this secret? Anyway, moving on. Let's go make a part for this little guy right here. Drawing parts. Oh, you know what? Let's redo that. Okay, and go back in. Yes, I know I did not finish installing my copy of KiCad. I don't remember how to do that. New part. And this part is called a Mic 90YC5. You move up, and your pinout is 1 is plus. 2 is V minus. Three is in minus. Let's also name that in plus. 4 is out. And 5 is V plus. Okay, so that's kind of what that should look like here. Let's go draw a little part around it so people will actually be able to recognize it. Burp, 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 burp. And conveniently, we can also move the whole thing down 1 unit. Look at that. That goes there, that goes there. That makes it impossible to read. Okay, fine. Also, I typed that wrong. Pin name V plus, pin number 5. V minus, pin number 2. I think I squished that a little bit too much. Let's back out some. Okay, that looks like a fairly readable part. Oh, there it is, fill background. Okay, so I'm gonna go export this, mic 920YC5. Is that, yeah, okay. I'm gonna drop this in. Mic 20, oopsies, I forgot to add the thing. Add part, KiCad Y. There it is. Yeah, I know I did not do the proper installation. Mic 20YC5. Okay. What I'm going to do is dump that output into there. And now I have in minus and in plus, and I'm probably going to want to play with them. If I had to guess, I probably... if somebody's up for it, I don't know if anybody in here is, I should probably just do the job myself. I want to make sure I can actually, this can read differential voltages at the rail. Okay. Normally use rail-to-rail parts, so I don't even really know what I'm looking for here. What I want to make sure though is that if I ground one of these inputs to just ground, that it won't freak it out. It might. Makes me a little bit worried. I've forgotten what the type of thing is called though. Let's see here. I probably want to guard that. I want to make it a little bit safer. So what I'm actually going to do is I'm going to put a diode, if I can find one. I don't know if I have one. I may have to. Oh, whatever. Let's just wire up the rest of this stuff right now. I don't know what I'm going to do with the negative side there yet. I got to figure that out. Though this side is totally good for hooking up to 12 volts. Not actually 12, but it is going to be pretty good. And this is going to have to come from a connector. Okay, I've had it. I'm going to have to figure out how to do this. Thank you! The mail came. Moving on here. So, app cache search KiCad. Maybe it's KiCad library. Ha! That might be it. Let's see, what is chat saying? Look, £2.30, way too expensive. I'm telling you, ESP8285s, they're cheap, and they got wireless built in. Just saying. Oh, input common mode range. Hey, perfect. That's what it's called. Input common mode voltage. They say it'll go from 0 to the full. Okay. Oh no. 3.25 to 3.25 at negative 5.5. Okay, so it looks like I will have to have at least like a volt or something, a volt and a half. Oh, okay. That's interesting. So what I actually need to do is try that. Oh, come on, you don't know what a KiCad. Okay, fine. Okay, whatever. At least now we have our libraries. Look, a diode. I can actually just put a diode in. So, let's see here. I want to have a diode here going to ground. And that's going to be footprint SM06. Then this one here, I'm going to need a connector. It's 102. This is going to be a SIL -2. Adam is playing some video game. I think The Witcher. Let's see here. So this hooks up here. Boop. This hooks up here. Just gonna have a little bit of bias. This is almost certainly going to need to have, I'm going to throw something there just in case. You might replace this with a something initially. So what I have going on here is I'm making a kind of a makeshift high-pass filter, but it's going to be an awful high-pass filter. So who knows, maybe this will work, maybe it won't. This is going to test a lot of things. This is probably as aggressive as I want to try testing today, considering I only have 2 hours left, 2.5 hours left on this live stream. It makes me nervous, but yeah, let's just give this a shot and see how bad this is going to be. Are we going to be able to do this or are we not? Let's see. I am going to have to find a part. Can you guys see that? I guess it's kind of visible. Hold on. Oh no, you guys are actually telling me useful stuff. Output swings limited by the maximum output sync current, sync capability, refer to the short circuit. Not in short circuit, so that's good. Very high impedance output. No, all of these things should be fine, because what's going to happen is I'm going to keep the sync locally, and everything is going to be able to be kept in sync by the lighthouse itself. So when it sends out a flash, I'm going to be able to watch that flash and sync off that flash. I do not still use Toper. It's just, I don't know, I feel dirty whenever I use it. I wish somebody made like an open source free version of it, but it just doesn't exist right now. Oh no, when I updated, all those changed. This goes to here, it goes to there, all those look fine. Ooh, that's using my AP1117 layout. That's a little rough. Yeah, I switched my components midway through, and you just really shouldn't do that with KiCad, but it's not 5 volts over there. I really don't like FreeRouter. It's just not. It's as much work to get things into and out of KiCad, but it doesn't even give you that much of a. It doesn't even route that well. Like, I can route better than it all the time. Whereas with Toper, every now and then, man, Toper will give me a run for my money. There will be times where I'm like, I've routed this perfectly. And then Toper's like, no, I figured out this faster way. Like, oh, you punk. Toper, you are incredible. So, now, first of all, let's look up some SOT. Hello? Oh, there it is. SOT-23. Let's see. 1, 2, 3. Is that match up with the data sheet here for that diode? Let's see. SOT23. Oh, that's the wrong thing. I should have noticed because the picture is different. That's a combination of 4 diodes, but I don't really want to play with that right yet. I want to get something a little more basic working first. So they claim 1, 2, 3. With it oriented up. 1, 2, 3. Spectacular. So that's an SOT-23. Okay. And that's set. Let's see here. Let's just export it and see what happens. You see that button there? You can kind of see it. Generate. Annotate. Yes, done. I should really make that stuff visible. Topper is straight up unbelievably good. I just do not know how Topper is as amazing as it is. As I was saying, Topper can actually beat me. And I'm not that great, but like something like Altium's auto router, like I know some people who try to use the Altium auto router, and it is a very sad thing. And basically all the commercial auto routers are just terrible, but somehow Topper's is just unbelievable. And I can crush any other of the other commercial auto routers, but when it comes to like Topper, man, it's a heck of an auto router. Okay, let's import this. Net, read. Ooh, there's a lot of missing stuff. References, libraries. Nope, nope, nope. Manager. And library. It's doing something. I'm just curious, what did Dave Jones, what did he come into with the Altium auto router? Because, I talked to other people, other people are like, it's just fine, and I'm like, have you ever used it? Like, I'm really curious what other people have to say about the Altium auto router, because my experiences have just been so hilariously abysmal. Let's see here. So this will go whoop-de-doo around that way. Diode over here. Oh, that is not a comfortable. Why is that? Let's try flipping this. Adam, back in the other room, is playing a video game. That's what the noise is. At any rate, let's try this now. Let's see if this net. Maybe I can shrink this. No, if I shrink that back, then. Ooh, wait, I can do that. Okay. Yeah. Yep. 2-layer. Yeah, I guess one of the ways that a lot of the people I work with, they'll get around Altium auto routers, they'll give it like 8 layers. I'm like, that. Why? It's just needlessly. You can do something by hand in 2. Okay. Yeah, there's a lot of. Whatever. Let's just start placing these things, then we'll add the. Ooh, is starting to fit. No, it's still bad. What is up with that? Is that really the only way? Let's try flipping it back. What am I doing wrong here? That should totally... Maybe that's it? There should be some way to... Ah, okay, that's perfect. Good, good, good. Those look kind of big. Oh, you know what? Huh. Let's see here. That's entirely the wrong footprint, but let's just use it anyway. The spacing is right. Let's try this combination. Okay, that lists that out. Delete that. Let's try that and see if it works out. Yeah, I guess SW1, C5. What are these? These are... C805s. Okay, whatever. I guess I'll use them. And then tactile. I'm going to definitely need to get that. That is tactile. Yay! Tactile. By the way, this is the footprint from Awful Land that we tried with the MagFest badges, and that was what messed it up. So I'm just going to start using it now. Just, you know, because I'm a doo-doo head. There we go. That looks good. Switch is going to be somewhere in there. This is going to be somewhere there. This is something like that. Let's move. Whatever. No reason for this to be compact since it's just a prototype. And since we don't need to get a really tight design, I think I'm going to go loosen up some of the design rules. Let's make it 0.1 and track width is 0.12. 4. Sure. Okay.
broadcasting?
Yep, it is broadcasting. People were commenting about your
Witcher?
yeah.
The Witchist?
Yeah, by the way, yeah, Jamie, it's definitely going to be much lower latency than a normal Wi-Fi stack. Whatever, it's connected through. So, like this right here, I don't need to make that jumper there because these are already connected, like, by metal inside the part. It's not like some things where you actually have to like connect it, otherwise terrible things happen. Wait, is this the newer one? Aha! It is the newer one. Sweet! Push-pull routing. Oh, I have to turn that on. How do I do that?
Where did all this extra hot chocolate come from?
Magic Land?
Because we have a disgusting amount of hot chocolate already.
But that doesn't have marshmallows.
Let me count the ones that have marshmallows. That one doesn't. No, I guess most of them don't. I guess you can just add real marshmallows.
Yes, but that's effort and something. Next thing we have to do, we are going to have to then go to DigiKey, and we will have to figure out exactly what footprint this is. I'm pretty sure it's not an SOT23. Let's see, which one did I get? I got the one SC70. Let's see, what is that? A thing I can just place? Install. Probably not. SC75, 353. It's an SC53. Ooh, that is tight. And it violates the rules. Okay. Clearance 10 mil. Still violates. You know, I will fix that. This looks pretty cromulent. Let's use this part. Footprint is that thing. And I didn't know that was E. Yeah, there's a ton more. Like, I can go design something and build something and have it working, and it's still less than 5% of the way to a finished product. If you have to do like FCC stuff, you're like 1% of the way to a finished product. Just because something works on the bench, you are light years away from a functional, like, it can go on the shelf product. Like, my gosh. I mean, just as an example, Neon FM, that arcade game that we made, we had a functional prototype done in like a month, but we've been working on it for, I don't know, like 2-3 years. Oh gosh, now I forgot what I was doing. Ah, whatever, let's just output it and I'll remember what I'm doing when we've gotten a little bit further. Go. Yes, done. Oh, I remember what I was going to do. I was going to go suck this guy's that. Oh, that part might be different. So let's find out what the part is. I feel like I should probably have a third pin, or two more, that has ground and the power, so I can get to that. It's probably going to be useful. Con 04. Minus. Thus, we can no longer use that part. It will be this part. Effort. Did I actually say that? Yeah, EMC testing is a complete pain. I am using Linux Mint. Net, generate, done, good, go, done. Net, read, yes, done. Okay. Let's see here. Let's go drop this over here somewhere. I don't know how this is gonna work. Ugh. So many parts. Don't know where they're gonna go. Looks like that would work. I'm gonna pull this up some. That is definitely not a 10 microfarad. That is more like a 0.01, or let's say a 10. This is probably a 10K. Oopsies. Who did I just make a moderator? You? Okay, that was a little weird. Anyway, I do have a current feedback loop. You may not see. Okay, I don't have a current feedback or a feedback loop, but that's because as the frequency goes up, the amplifier itself. So okay, this is a really kind of interesting thing about engineering when it comes to these sorts of parts in general. There's a lot of extra components a lot of engineers put in, and a lot of them are really, really unnecessary. So for one, if what you want to do is get as much gain as you want and then have a low pass thing down here, and you have as much as possible up here, like a gain, you can just have no feedback basically, and then it'll naturally taper off at the higher frequencies. I just realized what you were talking about. I don't think that the open gain at low enough frequencies is going to be enough to mess with it though. Good call. I will throw a resistor in there just in case. Just in case. I don't think I'm going to need it, but I'm going to say no populate for right now. I don't think I'm going to need that. I think it's just going to naturally work. But let's find out. Yes, I'm using exactly. But you are correct that that might not be sufficient. That might not be the way to go. But I don't know, and I don't really want to over-engineer if I don't have to. Oopsies. Move you here, maybe? That looks like a reasonable place. Maybe like that. So you go here. You go here. Maybe. This is going to be hard to plan. I might not be able to do it this way. Oh, so close. Okay, fine. Clearance 0.09. Ooh, actually. Track width 0.13. Hee, it fits. Okay, we're getting there. Should probably go like that, and this should probably go like that. Okay. No, this won't work. Huh. Okay, I'm going to just have to scrap. Really wanted to use that, but I can't. So I was trying to avoid using an extra capacitor by trying to use this here, but I realized it's not going to make any sense anyway, because one microfarad on that is not going to be enough to get rid of all of the nasties. So I really do need to get. We need two capacitors out here. So boop-a-doop. Copy, paste. Let's use a 10N. And I mean, maybe, no, even a 10 mic's not going to be enough. I really need that. This is going to be rough. This is really going to be rough. Really should have another one yet. That might be enough. Let's just hope for the best, and if it's not, we'll deal with the repercussions. delete some of these wires here because I'm going to definitely need to move some of this around. Should probably be a 1 UF. So what I have here is I'm trying to, because I have a charge pump, it's going to be super nasty. I don't have any 22 mic 0805 ones, so you're probably right. That would, yeah. I just don't have anything like that in any boxes already. Whereas I have a ton of 100 mic and 10 mic, and I think I have a ton of 100. I hope I have a ton of 100 mics. If I don't, this is going to get even worse. I guess I'll just have to route in between there. I think this is all I need. I don't really use QT. I'm pretty much addicted to raw draw. Considering we're not going to be printing a silk screen, that's not needed. What I will do though, I will add a I don't remember what you call this. Ground plane. I will add a ground plane. Oh man. Oh, it wasn't quite far enough. Whatever, I'll shrink these pads just an itty bitty bit more. Oh, it like reset the... I wonder why I did that. Okay, well, past DRC. Ooh.
How about this idea? Well, hmm. This is, I'm trying to right now design a kind of like a test bed to see how hard it's going to be, or if it's going to be feasible at all, for me to read the Vive lighthouse data with really, really cheap, awful parts. I just don't know if it's going to be feasible or what, but I'm going to go give it a shot. And I really, this is not going to work. I'm going to have to put it down a separate ground plane. Yeah, I know. Okay, let's see what this looks like. Okay. Oh, good, good, good. All the big nasty areas are now covered with ground planes. Well, not ground planes, but just planes. So that's great. That doesn't need to be connected. That's fine. That's a 10 mic. That's a 10 mic. I should probably write what some of these are on here. All of those are going to be 10Ks. It's going to be an ESP32. That's an AP1117. Guess I should write that. Probably write what some of these in here are. My guess is going to be this one should probably be about a 20K. I really don't know though. I've never used these photodiodes. I'm going to be using them in the reverse, whatever it is, reverse bias mode. So we'll have to just see. This is probably going to be 10N. And these are going to be whatever. This one's going to be 0.1U. Actually, this is probably going to be 1U is best. Here, what is that going to be? That's going to be I guess a 10K, I don't know. Maybe 100K? And So much of this is just guesswork because I just don't know the electrical properties of so much of it. This is just going to be a minus die plus. Minus D. And R7, that's going to be a no pop. At least probably a no pop, I don't really know. And that's going to be a 1U by 4. That's obvious, it's an ESP82 whatever. I don't know, man. This is probably gonna work. I mean, it's not gonna work, but it's. What did I do wrong? Oh, it's treating that as mechanical area. Okay. This looks okay-ish. Oh, I'm sorry. I had that off screen. I was eyeballing this. It looks right. I don't know why it defaults to wacky color mode, but SP30 12E goes there.
I think we're good.
I think. Whatever.
Only got 2 hours left.
Let's try it. Let's test this puppy out.
Oh no, Adam!
What?
Why did you have to do laundry now?
Why not?
Because I'm printing circuit boards.
Okay.
Ugh.
I don't understand.
The dust from the laundry messes up, well, whatever, maybe, hobbyist engineer problems. Okay. ESP power with op. Let's also get this committed. That's not it. No. Ah! Figured out my password. Why print when you can mill? I'm going to show you why you print when you can mill. Anyway, actually, I got a bunch of designs I want to throw out on this one. Let's go just do all the designs at once. That way I only have to print once. Not that it takes any time. Kidding, why print when you can mill? Why mill when you can print? Oh my gosh. Printing is king. Colors... Invert... Probably shouldn't have done that. Let's give it a fair bit of room. So I'll make it that big.
I am going to have to switch accounts. Give me a moment. Does that work? No, you can't do that. What? No. Oh man, where do the files go? Hold on. Maybe it's on this computer? It is. Oh, this is gonna be weird. Okay. Whatever. We're there now. Okay. We are gonna take you guys and slap you on this. Sure, whatever, let's just print them all. All I'm really going to do is 2, so no reason to print any more than that. If you guys are curious, these boards here are ESP32 boards. And I am just trying out a couple things with them. I'm trying to see if I can actually get it to 1 layer without any jumpers at all. I don't know if that's going to work out or not, but I think it would be neat if it does. least it's not me this time. Did I print my password in plain text? I didn't notice. Ooh, that's not going to be good. Okay, let's just do a test print. Can't believe it actually remembered all of my settings. Oh my gosh. Sweet. Let's see what this looks like. I print it once on regular paper to get it warmed up, and then I print it twice more on transparencies. Uh-oh. That's not good. So, a bit rough. I don't know why that's having a hard time. Yeah, I guess it's kind of hard for you guys to see, but the print quality is super low right now. Let's try printing another on. What the heck, printer? What is wrong with you? Why are you so sad today? Whatever. We'll just try it. Maybe it'll work, maybe it won't. Just have to expose it less. It's really weird though. I don't know what's causing that. Maybe there's some sort of static, maybe? Huh.
What the heck, printer?
I didn't spend $37 on you for nothing.
Ooh, that's not good. Wow, this is
Only getting worse.
You know what, whatever. I have never tried printing face down with paper.
Today seems like the right day to do it. Because when I print on paper, it seems just fine. I have never done this before. Let's just try printing on paper. No, the toner is relatively new, I think. Let's try blowing it out. Let's see if that helps. Oh, wow. Yeah, I think that might have been it. Huh. Let's try printing on transparency now. No. Still awful. Well, let's just try this. Somebody online said that I could take regular paper and put it face down and print with it. So
we'll just give it a shot. Take one of these other ones just in case. Hey, you know, whoever that was on there that said, why not mill? This might be a time when milling would be better. Because something is wrong with my printer. Okay, time to disconnect from the power sources and go downstairs. Let's hope that this works. I can still hear the washing machine washing. Hey, what's up? Hey. Ah! Mark, you are a lifesaver. You are a lifesaver, Mark. Mark points out that I was supposed to flip the design. Ha! Ha 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 ha! Let's go back upstairs. That also buys me a few more minutes for the machine to stop machining and being all loud. Thank you, Mark. Whew. Okay. Whoopsies. Huh. Look at that. I need more paper. Where is paper? There is paper. Whoa, what are you doing? Printer? Wow, it just keeps getting worse and worse. I know it's hard to see, but man, is it bad. Just don't get it. Whatever. I'll give it a shot. I should probably take my phone with me again, considering that just saved my butt. Such a bad print. Let's hope that the rest of this process is forgiving enough. I've discovered you have to use cold water when using Riston. Otherwise, microscopic bubbles will get underneath and make things very sad. You also have to find the end when you get Riston. Not gonna go well. Seas. Oh, too late now.
actually did not explode. Over at 1642 right now. Oh yeah, that's a good idea. Uh-oh. That's not good. There we go. Looks reasonable. How many viewers are in right now? Oh, it says, I think it says 165, right? It's pretty good. I wish I could get spray on resist. Oh my gosh, I want wrist on or positive so bad, but I cannot get it in America, and I don't know why. And it is so frustrating. And I want spray on resist. I want it. I want it. I want it. I do not know how to get it. So I have never, ever exposed through paper before. I have no idea if this is going to work. But I cannot use a transparency right now, so this is my only hope. We will see if this works. It's just like that. Be right back. I guess maybe 8 seconds under would be enough. We'll have to see. It's got to be cool before you pull it off.
I don't know. Maybe I can use 3-in-1 oil. Maybe. This is uncharted territory. Okay, maybe that is just made out of magic. Uh-oh, I got a text. I hope it's not one of you guys telling me I just did something drastically wrong. Nope. You guys probably have not seen this yet. This is my UV light source. It is about 50 watts, which I did not think was very much power. Boy, was I wrong. I will need a pair of sunshades. I'll just close my eyes. 1, 2, 3, 4, 5, 6. It seems like in the band that Riston is sensitive to, that ball was about 100 times more powerful. Oh my gosh. This might have worked. It's a little bit faint. Maybe I should have done it for a second more. Oh, many of the traces aren't going to work. Although on our thing it looks like it's going to be fine, so... Okay. Let's just hope for the best. Hooray! Looks like at least our boards are going to be okay. Even if most of the ones in the middle are not.
Uh-oh. I rinsed a little too hot. Whatever, our boards are going to be fine. Just because the others are toast doesn't mean it's all lost. By the way, that's all sodium carbonate, so it doesn't really matter. Like when you wash laundry with it, all that goes down the drain anyway. So you guys can see. So this is now basically plastic on the surface. You guys see down in there? Kinda. Sponge. Hi, Sponge. I get to use you once every now and then. I missed you, Sponge. Spongy Sponge. Sponge, Sponge. You know, this almost worked. I think maybe I should start trying to switch to a transparency-less system, one where I just use paper face down. So that would be a lot simpler. Also, maybe if I waited 7 seconds instead of 6 seconds at the development stage. Looks pretty good. I neutralize whatever's remaining with, they were 385 nanometer 100 watt LEDs. Man. Come on. I don't have children. Why do I need child safety things? Why do child safety things treat me like I am a child? Oh, you guys are going to want to watch this.
Just a little bit of rubbing alcohol. Get rid of any of the residue. Done. 15 minutes. Okay, 17 minutes. I'm not going to use that one.
Okay. Whew. So now I've got these boards made. Sorry for being quiet for so long. It would be a lot of fun if I could figure out some way to let other people control white text. Actually, I might be able to do that. Maybe next live stream we'll try that out. I'll try to make it so you guys can control white text. So all I actually care about here is our boards. That's all I'm going to be putting parts on, is our two boards. Let's go get some solder paste. It's not going to be enough. Would like these connectors to just be able to come off the end. One way to do that is to clip off any of the, there we go. What does ASMR mean? You are free to continue laundry. So you need to use the laundry room? No, I already have. Oh, you're done? Yeah. So I can do my laundry? Yes. Okay. Not that you haven't already been doing it. There's a lot more parts on here than I remember putting on here. It's going to take a lot longer than I had hoped. Only have about an hour left. Okay, so that's all good. That's those two. Let's see, is there anything else in here I have to worry about? I don't think so. I'm going to move on to box 2. Okay. I'm sure I've forgotten something in there. Back. I will not build the space dispenser, but if an automatic paste dispenser appears on my desk, I will absolutely use it. Okay, so those are all 10Ks, so... I actually don't like building things, I only like designing things, but in order for things that I design to be, physical realizations, I have to build them. Building is simply, for me, a necessary evil. Next up is the 10 microfarad caps. These originally came from Jameco. As far as I'm aware, nothing else like it exists. However, this does exist, so if you need boxes like it, you can get boxes like this. This one is Aid Tech brand, but I believe there's several different brands. 33 nanofarads, close enough. Do I really not have any 10 nanofarads? Oh, I do. Oh well. All I have is 22 nanofarads for that big one. $20K. Oh, I got 22. I do need a big cap though, which I may or may not have. That is completely the wrong part, but it might work. Big honkin'. Oops. I never pull parts off old boards. You can't trust the parts. It's just too risky. I mean, if I'm in a pinch and I need the part and it's on the old board, I'll take it off, but I usually avoid it. So much can go wrong. Okay. Okay, I'll be right back. puppy together. There's the op amp. Hi, Ben. I was hoping there'd be another bag in there, but oh well. Okay, let's get these puppies populated. Oh my gosh, turn over. Turn over. Why? There we go. Okay, I need to put more caps in. A to-do list. And need one more. What else do I need? 0.1-inch headers by 1. Okay. Ben Jackson, that is correct. I do intend to use the I2S bus as a high-speed 1-bit logic analyzer. And the big thing for me is I want to try to do it without having an envelope on the front end. I want to just try to shove the data in the port and see what happens. Oh, I only have 24% battery left. Hope this we can get this done in time. Yeah, I think if you were to use Capture Compare, you should be able to use an STM32 processor to capture, I think, about as many as 16 at once. But I want to leverage the power of the ESP, like its computational power, for my will, so I can do processing on that. The other thing I'm really, really hoping for, and I don't know if it's feasible or if I'm just, a dreamer, but I want to see if I can get extra data from the signal that's lost when you envelope the signal. I really think it should be possible to go get more information out than is currently gotten out into the triad semi part. My gosh, my hands are so unsteady nowadays. I think I might have a Wi-Fi badge upstairs. It was off by a whole thing. That's not good. I have to go shortly, but let's see if we have enough time to at least see if I can get that charge pump working. Okay, let's go for it. I'm just going to assume everything is perfect, which is a terrible assumption, but I make it frequently. And, yeah, let's see what happens. Oh, too hot, 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 hot. Step one is we see if this thing actually burns. Step two is we try to burn it with something useful. Okay. Am I in Ellicott by any chance? No, I grew up in Ellicott City, but I definitely do not live in. I don't know where Ellicott is. But no, I'm not. I'm in southwestern Baltimore. Ground positive. 2 pins here and here. Let's reorient everything. Oh, I'm well aware this is going to be bad news bears, everyone. Don't worry. I don't expect this to work, but I expect to learn something about why it won't work. So I'm going to be cloning the Kelvin multimeter project since it is pretty similar to what I'm doing here, insofar as trying to catch, use the I2S bus as a medium high speed reader thing. So I'm going to copy. Let's do that again. I not have... Oh, no. Well, let's... Give me a minute here. Ben, I am also very curious about this I2S thing. I'm really hoping that after 4 or 5 iterations, I get something that works. I mean, I know this iteration is going to be useless, but I really want to see if I can do some like clever processing in there. Grief, how big is the build folder for this? Okay. Oh. I'm going to have to give it the little 2-finger salute, which is I go boop, boop, make burn. Neat. That worked. That did not work. Why did that not work? FMDIO. That's not right. It might work. Why is that? What am I doing stupid here? Let's just try the other chip just in case. You were right, the camera did die. Oh, and it's... Oh, and I need to plug in. Let's fix that camera. Let's fix the audio. Hello. The wrong audio. Hello. Testing. Perfect. I'm gonna have to go. Let me see when I have to go. It is. I'm gonna have to go in about 15-20 minutes. It'd be nice if I could at least get this charge pump going in the next 15 minutes, though. Ship is 8266. ESP open SDK. All that looks right. And yet it does not boot. I did something dumb and I don't know what it is. Actually, I have a better idea. I will try flashing a different ESP that I know works. Uh-oh. Huh. Okay, apparently this one might not work, because I just shorted something out. Uh-oh. That's not good. Oh no. No. Oh. Okay. Maybe we're okay. No. I have USB. I do have USB back. Okay. So I'm going to continuity check that first. So that's not shorted out. So that should go in there. Oh, now it's fine. That was a little weird. It's backwards. Great, so something's wrong with my development environment if it's building out bad binaries. Probably was messing with something I shouldn't have messed with. What could it be? No, that's not a wrong baud rate problem. That's the chip constantly rebooting. You can see because it's flashing. Let's try a basic project. Hey Adam, do you want to go to Elevate worship thing tonight?
What?
The contemporary worship at church. It starts at around like 6:30ish.
Oh, nice.
Okay. What is going on? How is everything so broken? Oh, weird. Oh, it's an old version of ESP tool. Well, that's fine. That one says it's fine. Why is it not working? I don't want to deal with this right now. Okay. That was a dumb mistake. That does work. It's flashing. That's correct. see here. So how are we gonna debug this? Let's try a different project. Say ESP266 WS2012 I2S. Just gonna have to get a newer copy of the SDK. 1541. Okay, that looks new-ish. Is that just the patch or is that everything? That is just the patch. Call that. So stupid. Why have I forgotten what that is? Oh, live, there it is. Oh, don't have permission to do it. Yeah, this was dumb. I just have never built an ESPv266 project on this account, so... Please work. Apparently, my build environment is broken on this computer. That's just wonderful. You know what? I'll just use my laptop here. Get this. Let's plug this in here. Really? Okay, so it is actually just a build environment problem, and it is with my laptop. So I am going to put this away for now, and I might actually be back later on tonight if I can get the build environment working on my desktop, but nobody wants to sit around and watch me try to get build environments working. I hope you guys had some fun. I'm sorry we didn't get to do more interesting stuff. Maybe I'll be back later on this evening. Thanks, guys.